Hello YouTube, how are you? And welcome back to What the Math. Today we're continuing chapter 9 and we're talking about tree diagrams and also sampling with and without replacement. So let's get on with it and start our lesson. Okay, let's start with the tree diagram. This is a tree, just so you remember that we're talking about tree diagrams. So we've briefly talked about this before. This is basically when you have something that kind of looks like this. It's sort of like a tree, but not really. It's basically branches of different events, and they help you to calculate probability for when you have more than two events, and so on and so forth. And what we're going to be looking at is example 13 from page 276, just to kind of help you visualize this. So this is a question. There's a guy called Carl, and he's not really having much luck lately. His car will only start 80% of the time. So right away, you may want to rewrite this as probability. So this is 0.8. And his motorbike will only start 60% of the time, which is 0.6. And here we're asked to draw a tree diagram and also use the tree diagram to answer these two questions. And to answer this question, we have to actually visualize this. So we have a car, a really badly drawn car, and we have, oh my god, this is going to be really hard for me to draw, a motorcycle. All right, yeah, there's a seat here. Yeah, yay, motorcycle. So what we want to know is, what is the chance that both of them will start? So essentially this is our two events, and what you have to think about, it's not going to be a tree where you have car and motorcycle. It's not going to be this. It's actually going to be an event where first we're looking at the car as a separate event. So essentially what we have is, we have two branches. One says car and one says not car. And then we have another event, event number 2, our badly drawn motorcycle that looks like a caterpillar. And essentially this will give us two more branches, M not M and M not M. So this might be a little bit tricky to kind of figure out, but basically we're not looking at them at the same time, we're looking at them separately. So what is the chance that the car will start, and then what is the chance the motorcycle will start? And here we already have our probability. So for car, chance of having a car start is 0.8. So right away put it somewhere over here above your branch. This will help you remember what it is, and also will help you calculate the values later. Now, what is the chance that the car will not start? Well, it's 20%, right? 80%, 100% minus 80% is 20%, so this is 0.2. And this is not given to us. We actually have to calculate this value. Then we know that he has 60% chance that motorcycle will start. So for motorcycle right here, we're going to put 0.6. And also for motorcycle right here, we're going to put 0.6. And for motorcycle not starting, 0.4, because it's 40% left, so it's 0.4. And essentially, this is our basic tree for this problem. So we have two events with two branches each, and above each branch, we're going to write our probability. Now, this is how it works. Whenever you are trying to find the probability of two events using the tree, you actually have to cross multiply the values. So, for example, for our first question, both will start. So this will start, and this will start. So we have to take our first branch, which is our car, multiplied by our second branch, which is motorcycle. So in this case, it's going to be 0.08 times 0.6 of 0.8 times 0.6, and the answer is 0.48, which is 48%. And so this is the answer to question 1, probability of having both of them start. And for the second question, we're looking at the situation where he can only start a car but not a motorcycle. So essentially, he can only use his car. It means that it's not motorcycle, it's M prime. So here we're looking at this, let me change the color a little bit, this multiplied by this. So essentially, it is going to be C multiplied by M prime, which is 0.8 times 0.4, which will give us 0.32. And this is the answer for the second question. And in essence, this is how the trees work. So basically, step number 1 here was to make this tree. Step number 2, so this was number 1. Step number 2 was write down all of these values above the branches. So make sure that you have these values. Some of them will not be given to you, so you have to remember that the sum of all of these values in this branch will always be 100%. Here as well, 100%. This is also 100%. So if you're only given one value, basically what you're doing is you're doing 1 minus the other probability. So, or 100% minus the other chance. So here, if we are given 0.8, then this will be 0.2. If we're given 0.6, this will be 0.4. And so this is step number 2. And step number 3 is this, where you look at which probabilities are you looking at and then multiplying them. So if you're looking at event 1 times event 2, you're taking a look at this and this, or this and this. Okay, so let's take a look at another example, but this time let's take a look at an example where our samples are not being replaced. So in this case, our samples were replaced, meaning that both of these probabilities are independent of each other. So this was independent. But now we're going to look at something where it is a dependent probability. So how do we change our tree then? And specifically, let's take a look at an example when we have a jar or something, some kind of a container that has something inside of it where, well, let's just say we have like 5 yellow marbles in there. We have 4 orange marbles. And then we have 3 blue marbles. And so what we're doing here is we're going to be reaching into this jar with our finely drawn hand and taking out 1 marble at a time, and then seeing how the probability changes, because now the marbles are not being replaced, meaning that the total number of marbles will change, affecting our total probability. So here, this is what it's going to look like. So we have, for our first event, we have 3 branches. I'm going to draw them right here. So branch number 1, branch number 2, branch number 3, and this is our first step. And we have 3 possibilities here. We have yellow, blue, and orange. Now, what is the chance that we'll get a yellow? To get a yellow, we need to calculate how many yellows we have and then divide it by the total number of marbles. And here the answer would be 5/12. 5/12. And for orange, it would be 4/12. And for blue, it would be 3/12. Now, we're not writing probability, we're just doing fractions for now, because it's a little bit easier. We don't really need to know the probability yet, even though our final answers might be asking us for probability. So for now, we're just going to do fractions because it's a little bit easier to calculate. Now, this is our first event. Now, when we take out one of the marbles, well, and let's just say we took out the yellow marble. So the yellow marble is now gone. So there's no more yellow marble here. And now we have only 11 marbles left. And so what this will do is this will affect our new probability. So for our second event, for our second level branch, we're going to have something very similar, except that the numbers will change. And what will change here is, of course, the total number of marbles and the number of yellow marbles. So now we only have 4 yellow marbles left, and the total number of marbles is 11. So this will be 4 11ths. And same here, and same here. For blue, total number of blues is the same, but the total number of all marbles will change, so this will become 3 11ths. I know it's kind of hard to see the blue. I should have chosen a slightly brighter color, but basically this says 3 11ths. And finally, orange is 4 11ths, so this right here will say 4 11ths. Now, hopefully your tree will look a little bit better than mine, but what I'm trying to show you here is that your total probability will change. So here it was 5/12, here it's 4 11ths. So let's just say that one of the questions will ask you, so what is the chance that you pick a yellow marble followed by a blue marble? So how do we find this? Well, first of all, we'll look at probability of yellow marble, which is right here. And then we'll look at the probability of blue marble, which is right here. And what we do is we cross multiply them. So it's 5/12 multiplied by 3 11ths. And this will give us 1532nd, which is, in probability, this would be 0.114, 3 significant figures. Alright, and that's basically the answer, and this is how you do it. So essentially the main difference here is when you do replace your marbles, this will not change. This will actually stay the same. All of this will not change. Whereas when you do take out your marbles and do not replace them, or basically anything, not just marbles, but anything, your probability for the second level, for this part, will change and you'll have to actually recalculate it. So it's a little bit more challenging. And essentially that's it for tree diagrams and sampling with and without replacement. Hopefully this was clear, and thank you for watching, good luck to you, and bye-bye.